Okay, how do we go about proving this equation? How do you prove that two sets are equal? You can always keep your mic on and speak. How do you prove that two sets are equal? You show that the first set is a subset of the second set, and also the second set is a subset of the first set. Both sets that you want to prove that are equal should be subsets of each other, right? But how do you prove that one set is a subset of the other set? Speak up, people.
You take an element
I'm
of
not
one
teaching
set,
my laptop. My laptop is not funny. Yeah, we take an
uh,
element of the first set.
one set, first set, saying that it exists in a second set also.
Yeah. You say that one set is a subset of the other set if every element in the first set is also present in the second set. So you start with a random element in the first set and try saying that it is also present in the second set. We'll go with the set in the left hand side now. You take a random element, in the first set, which is a minus b minus c. Okay. Now, if x is a part of this set, a minus b minus c, what conditions does it satisfy? What does it mean to say that x is a part of this set? We have to use the definition of difference. If x is a part of this set, then x belongs to, see if x is a part of p minus q, then x belongs to p but does not belong to q. So if x belongs to a minus b minus c, you look at a minus b, you look at the set a minus b as the set p here. All right. So if x belongs to p minus c now, it should mean that x belongs to the set p, but p is a minus b here. All right. X belongs to a minus p, but x does not belong to c. Is that okay? Are you understanding or is it too simple? I don't know what's happening because I cannot see your faces.
We can understand, ma'am.
Okay. Next, what happens if x is in the set a minus b? What does it mean? The same way you're saying if x is a part of a minus b minus c, x then is in the set a minus b but not in c. If x is now a part of a minus b, it means that x belongs to a, but x does not belong to b. Look at this definition of difference of two sets to say this. And we still have that x not belonging to c, right? Where do we want to reach from here is the question. Why are we writing this? Where do we want to reach? Where do we want the x to be in? Which set? We want x to be in this set over here, right? A minus b union c. Now, if x is to be in A minus B union C, first of all, by this definition of difference, x should be a part of A, but x should not be a part of B union C. Okay? Now this x is already in A, so the first condition is there over here, right? The first condition is satisfied, x belonging to A. We still want x not belonging to B union C. How do we reach there from these two conditions that we have here? Can we directly say that x does not belong to B union C after that step? If yes, why?
Yes, ma'am.
Okay, why? Okay, x belonging to A as it is. After this, can we write x does not belong to B union C? Is it logically right to say that? If no, why? If yes, why?
Okay, X belongs to A, X does not belong to B, and X does not.
Yes? I can't hear you. It stopped midway.
Yes.
By definition, x does not belong to B or C. Okay. Yeah, you need to look at the definition of B union C now. What kind of elements do you have in B union C? When do we say that X belongs to B union C? X is a part of B union C whenever X is in B or X is in C. Okay, so if X is not in B union C, what does that mean? X is neither a part of B nor a part of C, because say if X belonged to B, then X would belong to B union C, right? If X is in any one of these sets, then X will be a part of B union C. So if X is not a part of B union C, it means that X is not a part of B and X is not a part of C as well. Because if X is in any one of these sets, then X will be a part of B union C. Okay, so that is the logic. If you have any question, you ask right away. Can I go ahead with this? Okay, so X, with this conditions that we've written here, X belonging to A and X not belonging to B union C, what can we write next? What can we write next?
X belongs to A minus B union C.
X belongs to A minus B union C. Using the definition of difference of two sets, X is a part of A here but not a part of B union C. So X belongs to the difference of A and B union C. So we started with X belonging to the first set, and now we are saying that X belongs to the second set. We took a random element X, so that means A minus B minus C is a subset of the second set, which is A minus B union C. Okay, this is the first part. We proved that the first set is a subset of the second set. We still have to show another part which says that the second set is a subset of the first set as well. I hope you're writing your notes. Writing it later, you'll feel demotivated to do that. It's better you write it simultaneously. If something that I've written is not clear, you please tell me. I think it's simple enough because we did one problem last class. All right, so now we need to prove that this set is a subset of the first set. Okay, so you take a random element, let's say the element is y. You take a random element of the second set, which is A minus B union C. Okay, if y is in this set, what conditions does it satisfy? What conditions does it satisfy? This is the
Belongs to
second
A.
part of the proof. Yes?
Y
Then
belongs to
then
A.
y belongs to A,
What does
but
not belongs to
y
B,
does not belong to
B and C.
union C. Okay, what next? We'll write y belonging to A as it is. What do we get from y not belonging to B union C? What conditions can we derive from this? Before we look at what conditions can we get from that, you should know what do you want from y not belonging to B union C. What do we want? We want y to be in the first set. For y to be in the first set, firstly, y should be a part of A minus B. Just give me a moment to clear this. We need this y to belong to this set, the first set over here, A minus B minus C. Okay, y will belong to this set if y belongs to A minus B, but y does not belong to C. Okay, so we still want y not belonging to C here. We didn't get that. Now, if y belongs to A minus B, we should have y belonging to A but not belonging to B. Okay, so we need these three conditions to say that y belongs to the first set. We already got y belonging to A. We still want y not belonging to B and not belonging to C. What do we have here? We have a y not belonging to B union C. How do we get y not belong to B and not belong to C from here? Is it straight? Is it just the next step? Or do we need something in between? You can put your answers in the chart as well. I'm looking at it. Okay, it's direct, right? The meaning of y not belonging to B union C is that y does not belong to B, nor does it belong to C. Okay, because if y was in any one of those two sets, B and C, then y would be a part of B union C as well. So this is direct. Y not belonging to B union C means that y does not belong to B and it does not belong to C. So yeah, if y belongs to A but not belongs to C, then B. If y is a part of A but not a part of B, it means that y is a part of A minus B by the difference of A minus B. And we still have y not belong to C, you write it as it is. Next, this means that if y is a part of the set A minus B but not a part of the set C, then y is a part of the set A minus B minus C. So we've reached the first set. So we started with a random element y in the first set, in the second set, sorry, and now we say that y is in the first set. So what was the second set again? It was here, it's here. It was A minus B union C. Since y, a random element in the second set, is now also in the first set, the second set is a subset of the first set, which is A minus B minus C. So we proved both inclusions here. In the first part of the proof, we said that the first set, a subset of the second set. Now we are saying that the second set is also a subset of the first set. Since both sets are subsets of each other, they must be equal. Can you write that by yourself? Or I'll just write it here. The last line that you need to write in your notes should be this. Thus, the question itself, the set A minus B union C is equal to A minus B minus C. All right, can we move on to the third problem? Any questions on this one? Okay, at least tell me what the question is. Someone, come on. Tell me what the question is. Third one. You've written it in your notes. Come on.
A minus B minus C equals to A minus C minus of B minus C.
Okay. B minus C, is it? All right. Yeah, take a random element in the first set. Same way of proving. You take a random element, let's say x in the first set, which is A minus B minus C. What does it mean now? If x is a part of the set, what does it mean? Then x is a part of A minus B, but not a part of C. All right. What do we want here? We want x belonging to the second set. Okay, x will belong to that set. Firstly, if x is a part of the set A minus B, all right, look at this set as the set P, look at this set as the set Q. Okay, if x belongs to P minus Q, then x is a part of P, but not a part of Q, where Q is B minus C. Okay, if x is a part of A minus C, it means that x is a part of A, but not a part of C. If x does not belong to B minus C, what does that mean? Is a bigger question now. Anyone? Okay, I'll ask that question later again. We'll write what, if x belongs to A minus B, then x belongs to A, but does not belong to B. And we still have x not belonging to C. Okay, we need x belonging to A here, x not belonging to C, that we have with us. Now, another condition x must satisfy is x not belonging to B minus C. Right? How do we get that? When do you say that x cannot be part of this set? The difference of two sets B and C. When do you say that x cannot be a part of a B minus C? Look at the definition of difference of two sets. If X should be a part of B minus C, then X mainly should be a part of the set B, right? I won't show you the slide. You have your notes with you. Flip through the pages and look at the difference of the sets P and Q. If X should be a part of P minus Q, then X should be a part of P first of all, and then it should not be a part of Q. Okay, but when can you say that X cannot be a part of P minus Q at all? What is the main condition there? When can X not be a part of the set P minus Q? For X to be a part of P minus Q, firstly, X should be a part of P, right? So if X is not a part of P minus Q now, what does that mean? X is not a part of P at all. Yes.
X does
Yes.
to P.
Yes. See, if X belongs to B minus C, then X should belong to B, but not C. Right. Now, if X does not belong to B minus C at all, it means that X does not belong to B. It doesn't matter whether X is a part of C or not. If if X is not a part of B minus C, it directly means that X is not present in B at all. Okay, then you needn't discuss whether X is a part of C or not. Since X is not a part of B, X can never be a part of B minus C. Any questions here? Okay, what I actually want to ask now is, see, we have X not belonging to B here. We have X not belonging to B. If X does not belong to B, can you say that X does not belong to B minus C as well? This way. We discussed this condition. If X does not belong to B minus C, then X will not belong to B, right? I wanted to discuss this way now. If X does not belong to B, does it also mean that it does not belong to B minus C? Is it direct? Yes. Because if X should be a part of B minus C, then X should be a part of B. But if X is not a part of B at all, you cannot go ahead and speak about B minus C. Okay? For X to belong to for X to belong in B minus C, X should first of all be a part of B. But if X is not a part of B, then it's not a part of B minus C as well. So it's direct. Okay, so we have X belonging to A, and then we have, I'll rewrite this, X not belonging to C. Okay, I'll rewrite this. So this is not, this implies the same step rewritten. The X not belonging to B, I'll write over here. So now this means that the X belonging to A and not belonging to C means that X belongs to A minus C. All right. And if X does not belong to B, it means that X does not belong to B minus C. We're writing this because we want X to be in this set over here, right? This set over here. What step next? What do we have next? X is a part of the set X A minus C, but not a part of the set B minus C. What does that mean? X is a part of, you look at this set as P and you look at this set as Q. If X is a part of P but not a part of Q, it means that X is a part of P minus Q, where P is E minus C and Q is P minus C. So we're done here? Oh, we're done with only the first part. Okay, so this means that we took a random element in the first set, proved that it is in the second set. So it means that the first set is a subset of the second set. Second set being A minus C minus P minus C. If something is not clear, you please let me know. I know I'm writing more trashy here. Also, if there is a solution to scroll it down more easily, please let me know. Okay, to prove that the second set is a subset of the first set as well, you start with a random element in the second set, which is A minus C minus B minus C. If there is any question, you can stop me in between and ask, no problem. Or I'll just go on doing this. All right, so if Y is a part of A minus C, but not a part of, yeah, sorry, I'm saying the next step. If Y is a part of A minus C minus B minus C, then Y is a part of A minus C, but not a part of B minus C. This implies Y belongs to A, but not C. Y belongs to A minus C means this. And Y not belonging to B minus C, what does that mean? Y belongs to A minus C means Y belongs to A but not C. Now Y does not belong to B minus C. What does that mean? Does not belong to B nor C. Now, most students I've observed, they write Y does not belong to B as well as Y does not belong to C. Okay, the reason Y is not a part of B minus C is because Y is not a part of B. It doesn't matter whether Y is a part of C or not. Even if Y is not a part of C, okay, and Y does not belong to B, then Y cannot belong to B minus C at all. Okay? If Y is a part of C, then Y cannot belong to B minus C. Even if Y is not a part of C, Y will not belong to B minus C if Y is not a part of B. So Y not being a part of B is what matters whenever Y is not a part of B minus C. Okay, you can go to the video again if you've not understood in detail. But this means that Y is not a part of B. You need not write Y is not a part of C also. Okay, this statement means this. What do we want from this now? What was the first set again? We have A minus B in the first set. How do you get Y belonging to A minus B from here? You just rearrange these mini statements that you have. We already have Y belonging to A. To get Y belonging to A minus B, you put this statement over here. Even if you don't put it, it's fine. But I'll just rearrange so you understand. So now this means that Y is a part of A minus B, and we still have Y not belonging to C. All right. So yeah, this means that Y belongs to A minus B. If Y is not a part of C, then it belongs to A minus B minus C. Okay. So in this part of the proof, we proved that since Y belonged to the second set, it was a random element. The second set, which was A minus C, the second set was A minus C minus B minus C. So this set is a subset of the first set, which is A minus B minus C. So we proved both inclusions. In the first part of the proof, we showed that the first set is a subset of the second set. In this part of the proof, we showed that the second set is a subset of the first set as well. So these two sets are equal. So in the last, I wanted to write, so please write in the end, thus the first set is equal to the second set. Okay, I'll not write it. Please fill in for me. Any questions? Any questions?
No, ma'am.
Okay, if you have questions, you can stay back. The rest of you can leave the meeting. Thank you for attending the class. I'll see you this Saturday.
Thank you, ma'am.